Okay. Yep.
Good afternoon, everyone, and all my fellow friends and nature. So today, me and my teammate, so we are going to explain about the climate between United Kingdom and Malaysia. So the first is talking about the latitude and longitude. So for Kuala Lumpur, Malaysia, latitude is 3.1357 and its longitude is 101.688. So, and in London, England, United Kingdom latitude is 51.5 and its longitude is negative 0.13. So, the distance in kilometer between Malaysia and United Kingdom is 10,546 kilometer. And the time between Malaysia and United Kingdom are 7 hours different. So over here, the example are like the current time is example for 9:25 a.m. and United Kingdom are 2:25 because it's 7 hours different.
Mhm. Good.
So the date are the same, so they didn't have different date. So everything are almost the same. And the coordinate, this is the longitude and the latitude coordinate. So this the time zone are following Asia and Europe because United Kingdom is under Europe.
Mm-hmm.
So the next are the distance from the sea of Malaysia and United Kingdom. So the UK lies between the North Atlantic Ocean and the North Sea and comes within 35 kilometers of the northwest coast of France, from which is separated by the English Channel. Northern Ireland, Wales, and western part of England and Scotland, being closest to the Atlantic Ocean, are generally the midst, wettest, and windiest region of the UK, and temperature range there are seldom extreme. However, the eastern area are drier, cooler, and less windy, and also experience the greatest daily and seasonal temperature of variation. So this is the example of the Northern Ireland, Wales, and the western part of England and Scotland. These are the weathers currently rainy and mist, uh, wettest and windiest days. So these are the Wales are quite near from the um, Atlantic Ocean. Yeah, this.
Okay.
In Malaysia, distance between South Atlantic Ocean and to Malaysia is 2,372.26 km. The coast have a sunny climate with temperature ranging between 23 and 32 degrees Celsius and rainfall ranging from 10 to 30 cm a month. The lowland have a similar temperature but follow a more distinctive rainfall pattern and show very high humidity level. And the highland are cooler and wetter and display a greater temperature variation. A large amount of cloud cover is present over the highlands, which have humidity level that do not fall between 75%. So these are the weather we have in Malaysia. Um, if not the rainy day or a very sunny day, very hot day. So next I gonna pass to my teammate.
Hello.
Hi.
Um,
Mm.
my topic is sun angle, which is to determine how the country affected by sun ray radiation. And in a year, because all we know Malaysia is at the equator, so the annual average daily solar radiation of the peninsula of Malaysia during 1 year, like take an example, in 1 year has been between 13.67 per day and 17.18 per day. And the highest solar irradiation was estimated as 19.28 per day in the month of January, while the lowest was 10.53 per day recorded. And we can find the current average of UK. The annual solar resource is 101.2 and ranging from 128.4 in the south of England to 71.8 in the northwest of Scotland. And it seems likely that climate change will increase the average resource in the south of the UK while marginally decreasing in the northwest. That's all from us.
Only that?
Yeah.
All right. Okay. I felt like there's something missing, but never mind. I would like to see the next group. Then I can comment because I felt there's something missing. Next group is the girls group.
Can you see my screen?
Yes.
Okay. So, good afternoon to Mr. Farid and my fellow friends. My name is Jessie and my group members are Vida and Chengwen. So today we would like to present the differences between Malaysia's and Australia's regarding the climates. So Australia has 4 seasons, which are summer from December to February, and autumn from March to May, winter from June to August, and the last one is spring from September to November. While in Malaysia has 4 seasons too, which is the northern monsoon, and the second one is the first intermonsoonal period, and the third one is southwest monsoon, and the last one is the second intermonsoonal period. And this monsoon will cause Malaysia's heavy rain and cause flooding too. So, what are the factors that influence climate? The first factors is latitude, or known as distance from equator. Temperature will drop when it is located far away from the equator. As we can see, the latitude of Australia is 25.2744 to the south, and it is located in the temperate zone. So the sun is at a lower angle in the sky, and the sunlight has a larger area of atmosphere to pass through, thus more energy is lost and the temperature is cooler. While in Malaysia, the latitude is 4.2105 to north, and it is located in the tropical zone. The sun is directly above the sky, and the sunlight has a smaller area of atmosphere to pass through. Thus, less energy is lost, and so Malaysia is hotter compared to Australia. As we can see on the map, the distance between the Australia to the equator is greater compared to Malaysia, which is here, is smaller. Yep. So when the location is further away from equator, the temperature will be colder.
Yep.
So the second factors that influence climate is altitude, or the height above the sea levels. So temperature usually decreases by 1 degree Celsius for every 100 meters in altitude. So Manson Peak is the higher peak in Australia. As we can see, the temperature at the sea level, which is -1 degree Celsius, is higher than the temperature at the peak, which is -22 degrees Celsius. It is located at the same place, but the temperature would be different, depends on the height of the places.
Yep.
Next would be Malaysia, Mount Kinabalu in Sabah. It is same when the temperature, the temperature above sea level is lower than the temperature at the base. As we can see, when the place is higher, the temperature would be colder. For example, the elevation is around 4,000 meters and the maximum temperature could be 4 degrees Celsius, while on the ground, mostly on the ground, the temperature is higher, which is 24 degrees Celsius. Why? This is because the atmospheric pressure is lower at a higher altitude as the total weight of air above is low. It then causes the temperature to be colder. However, the atmospheric pressure is higher at the sea level because the total weight below is high, thus it is hotter on the ground. This can be explained when we put a balloon fly high in the sky, it will explode because the air in the sky is lower pressure compared to the pressure on the ground. So yeah, the balloon will explode, mostly will explode in the high sky. So that's all from me, and I would like to pass these presentations to Cheng-Wen. Thank you.
Okay, hello, sir.
Hi.
So, for the distance from the sea in Malaysia, Malaysia is surrounded by South China Sea, and at the east coast of Peninsular Malaysia is directly by the north monsoon. And the rainfall in November and December is very rich. For example, in Kota Baru is a city that near to the border of Thailand and East Australian city. So in the February is the best month to travel because it's too hot. Moreover, the sea at Kota Baru is warm throughout the year. So on the other side, for another example is Penang Island. Penang Island is proximity to the island of Sumatra and is also susceptible to dust particles carried by wind from perennial but short-lived forest fires. Moreover, it will also occur an annual phenomenon known as Southeast Asian haze in Penang Island. So next is in Australia. In Australia, the seawater always plays an important role in changing the weather condition. The most popular region has a pleasant climate on the east coast. Besides the southeast, the southwest of Western Australia experience cold front and wind from Antarctica. And Western Australia is very hot. It's very hot even in coastal areas. For example, in Port Hedland, the average daily temperature is 31.5 degrees Celsius, and the January is the hottest month. Besides, the rainfall is very low in Port Hedland, it's only about 300 mm a year. And the sea near the Port Hedland is warm throughout the year, especially from December to April. The average sea temperature is between 27 degrees Celsius to 29 degrees Celsius. On the other hand, the climate on southern areas is Mediterranean with mild and rainy winters and warm and sunny summers. It is because it's being too close to the ocean, so it makes the summer windy. So sometimes it will occur a heat wave because proximity to the desert. For example, in Perth, the daily average temperature is from 12 degrees Celsius in July to 24 degrees Celsius in January and February. Besides, the temperature in Perth Ocean is cool all year around. So next, for the ocean current in Malaysia. In Malaysia, the eastern part of Peninsular Malaysia is characterized by a strong western boundary current and two anticyclonic anti-systems. So the western boundary current flows northward along the east coast of Peninsular Malaysia to the southern tip of Vietnam, where it changed the direction and flows eastward at approximately 7 ON. In Australia, Prevailing and Zihan current, and third is Antarctic circumpolar current, and the last one is the Indonesian true flow. For the first East Australian current, the East Australian current is moved south from near Fraser Island in Queensland to the east coast of Tasmania. East Australian current is usually stronger in summer, and when it reaches the further south, it often brings northern tropical species such as tuna. So for the second one is Prevailing and Zihan current. So starting from halfway along the coast of Western Australia, Prevailing current flows southeast through the Great Australian Bight and arrives at the west coast of Tasmania in the form of Zihan current. So this ocean current is stronger in winter and is recorded to travel south by passing the southern coast and again north to the Freycinet Peninsula, which is located at the eastern of Tasmania. So for the third one is Antarctic Circumpolar Current. This is the third current system, and it also the global conveyor belt originates in the Southern Ocean as the Antarctic Circumpolar Current. So this is an ocean current created by density and temperature variation in the water, which is thermohaline circulation. So the last is the Indonesian true flow. This ocean current brings warm water from the Pacific Ocean to the Indian Ocean through the Indonesia. So this is unique because it's the only area where the warm water from the equator flows from one ocean to another. So it is also an important source of heat transport to the Indian Ocean. So that's all for me. So I will to be.
Okay, good afternoon, sir and fellow classmates. I will present for our group prevailing winds. So what are prevailing winds? These are the winds that blow consistently in a given direction over a particular region or area in Earth. It also determines the weather and the amount of rainfall that a certain area gets. So for the prevailing winds in Australia, generally the prevailing winds come from the points between northwest and southwest directions. Specifically, prevailing winds differ per region in Australia, which are New South Wales, Victoria, South Australia, and Queensland. So I will be discussing the prevailing winds in New South Wales first. So in New South Wales, the wind, 39.6% of the wind comes from this region. Winds here are called the southerly bursters, which are expected from November to end of February. These bursters approach the region with a peculiar roll of clouds above the south horizon and extends both sides 15 to 20 degrees. When the southerly wind comes from southern Sydney, the towns are alerted because this southerly wind raises the temperature because it flows from the heated interior of Australia. Then the next is in Victoria, the northern wind blows for about 8%, while in southwestern it blows 24.1%, and southern winds with 20.4%. So during summer, northerly or warm quarter winds has 20% of the winds, and then southerly or cool quarter winds 4 to 6%. During winter, it changes, so the northerly winds become bleak and cold. So the hot winds are also known as the northerly winds. So when it comes, it is a signal that a cyclonic movement is coming. This is in front of a low pressure or a V-shaped depression that brings thunderstorms and rain. So the effect of hot winds is that they dry the surface and raises dust storm when strong. Then the next region is South Australia. The prevailing wind here comes from the southeast, especially during summer. So dry and cold northeastern wind moves to northwest and then brings showers or rain when moving to the southwest. During summer, the country is under the influence of the northwest monsoon with thunderstorms and heavy rains, while during winter, southeastern winds prevail more. And then lastly, for the prevailing winds is in Queensland. So the eastern part of this is the Pacific slope, which is rarely troubled with hot winds compared to the other regions. So when the hot winds come, it is only usually dry and accompanied with dust storm. Then I will be discussing the prevailing winds in Malaysia. So generally, the wind flow in Malaysia is light and variable, but the wind flow patterns have periodic changes from time to time, from which we can distinguish monsoons in the country. So the prevailing wind flow is usually southwesterly and light below 15 knots. So knots is nautical miles per hour. And then this is an example of the direction of the wind in Malaysia and the other neighboring countries.
Mhm.
So the northeast monsoon season in Malaysia, it has steady easterly or northeasterly winds of 10 to 20 knots. And then this affects the east coast states of peninsular Malaysia, where the wind reaches 30 knots or more with surges of cold air from the north. While during inter-monsoon seasons, winds are light and variable, and the equatorial trough lies over Malaysia. So the equatorial trough is like a low pressure area. Then from April to November, typhoons develop in the Pacific west part of the Pacific Ocean, which moves west to the Philippines. Then from the Philippines, it then goes to the southwest. It goes southwesterly winds to the northwest coast of Sabah and Sarawak, where the winds strengthen up to 20 knots. We can see the effect of land and sea breeze on the general wind flow pattern in the country through the clear skies. During sunny afternoons, sea breezes of 10 to 15 knots develop tens of kilometers in the land, while during evenings, the land breeze develops in coastal areas. So that's all for the prevailing winds in Malaysia. So for the specialty, we chose for the Australia is the fruit, which is quandong, or the native peach. So it is widely dispersed in central deserts and southern Australia, used to stew to make pie filling, and is usually harvested from orchards in August to December. While for Malaysia, we chose durian, and durian crops are suitable for planting in areas with rainfall between 1,800 mm to 4,000 mm per year. Then the temperature should be between 27 to 35 degrees Celsius. So Malaysia fulfills the requirements above, so durian can be planted. So for the next part, I will pass this on to Changwan. Thank you.
So at the end of our speech, there are 3 questions for you all. First question will be, why latitude or the distance from the equator can influence the climate? And the second question will be, why distance from the sea affect the temperature of a place? And the last question is, what does prevailing wind determine? So that's all from our group. Thank you for listening.
Okay. For the questions, can you go back to that slide? All right. So, other students, what are the answer for the question number 1? Why latitude, or the distance from the equator, can influence the climate? Nobody know? What about number 2? Why the distance from the sea affects the temperature of a place? Come on, guys. Nobody know? Or don't know, don't want to answer? Distance from the sea affects the temperature of the place is because of, yes, why the distance from sea? Your answer was apa tadi? Sea breeze and land breeze is the factor, but why the distance is effect? Nobody know? Come on. All right, girls, do you know the answer? Just share the answer then, since nobody know the answer.
For the first questions, the answer, because the sun is at a lower angle, so the temperature will be cooler.
Yes.
Or maybe when the sun is direct above the sky, the temperature will be hotter.
Yes.
For the,
That's
yeah.
true. Good. The okay. The number 2, Chua also give answer. Water absorb heat and hold it for a longer time. So, what do you think the answer with this answer, Jesse or your friends? Ocean has higher heat capacity. What do you think, Jesse? Is this a good answer? You can look at the chat. Answers from Benjamin and Chua. Actually, yes, water can absorb the heat from the sun and hold the heat longer. That's why it is can release heat during the night. So this is actually somehow control the variation of temperature. Temperature near the place have a moderate temperature than a place away from it. Yes, means that temperature nearer to the sea will be more moderate and the variation is lower compared to the place that is further from the sea. Next would be the last one, the prevailing winds determine. What does the prevailing winds determine? Prevailing winds is the one that is because of latitude and position, the winds is flowing certain direction. There are many other kinds of winds, but prevailing wind is the one that is very strong and the most natural. So what's the answer, guys?
Rainfall, is it?
Yes, it also bring rainfall. That's one of it. Others? No answer. Jesse, what's the answer for this number 3?
What about humidity, sir?
Humidity depends on where is the, yes, it's part of it because depends on where the prevailing winds come from. If it is come from the, for example, Australia, that comes from Antarctica, it brings humidity, cold wind. If it is come from the north, which is Indonesia, brings a warmer wind. So it's quite different. Okay, so Jesse, do you have the answer for this number 3?
I have the. It determines the weather and the rainfall as well, but based on its direction.
Yes.
Yeah.
Rainfall. Wind farm. What is wind farm? From, I don't know what is wind farm. Chopin. Never mind. Okay, so this group, Jesse group, very good. You did all the things that I request you to do. Okay, so let's move on to the next group. I think there is the Yusuf Tariq.
Can you all see my screen?
Yes,
Yes,
we can see it.
can, but I think it's a bit small. I think you can maximize the screen. But
Sir,
now I
would you
cannot
like
see.
us to open our cam?
Now cannot see. Um, okay, now I can see. But can you make it full screen?
Yeah, yeah. Okay, we shall start now.
Hi, good afternoon to Architect Faris and my fellow classmates. My name is Ben, and these are my group mates, Tariq and Yusuf. Today, we will be presenting on the climate and cultural diversity of the United States. We will start this presentation with the types of climates in the United States of America. Now, let me introduce you to this country. The United States of America, with a land area of over 9.8 million square kilometers, is the third largest country in the world, just behind Canada and Russia. Now, interestingly, the land of the United States stretches from the equator all the way up to the upper portion of the northern hemisphere. So as a result, the climate of the United States varies drastically from one region to another due to the difference in latitude. Additionally, given that the United States occupies such a large land area, it is inevitable that it also possesses a wide range of geographical features, including mountains, dry deserts, beaches, and many more. So this also contributes to the diversity of the climate in this country. So here are some geographical facts. Firstly, the United States is located in the North American continent. It has a land area of 9,826,675 square kilometers. And this map shows the general regions of the United States. Now, this country can be separated into several regions, including the Northeast, Southeast, Midwest, Southwest, West, Alaska, Hawaii, Caribbean territories, and Pacific territories, and each region possesses different climates depending on its latitude. So I will now pass the presentation to Yusuf for the next part of the presentation. Yusuf?
Azam, kau nak buat ke tak? Kamu tak sikat kan? Tak cakap. Kami tak sikat. Tak masuk asal. Cepat sudah. Nanti kan ayah nak bunyi cepat sudah. Kamu tak expect for me. Tak orang tu tak tahu. We have to.
Okay, who is presenting now? Is it Tariq or Yusuf?
It's Yusuf now, sir. I think he has something wrong with his line. Hold on, sir.
Okay.
Sorry about that.
All right.
So we're so sorry for the mishap. Let me try to reach him as soon as possible. Give us 1 minute.
Uh-huh. Okay, so
So we're so sorry about the mishap. We're trying to reach him. He kept disconnecting.
I see.
All right, so it's okay. Tariq will take over his part for now.
Hi and good afternoon, AR Faris and my fellow classmates. I'm Tariq and I will be talking about the desert climate of the United States. The desert climate is located in the southwest region of the United States. These include the states of Arizona, New Mexico, Colorado, Nevada, and Utah. Hot and dry seasons can be found in this climate. The temperature can range from 10 degrees Celsius to a whopping 52 degrees Celsius.
Hello.
Hi. Wait, let me check again. Tariq is already mute, and then Yusuf, are you presenting?
Yeah. Yeah, just 1 sec.
Okay.
I'm sorry. So, which part are we in?
The desert climate.
Okay. The desert climate, it's located in the southwest region of the United States. It's the states of Arizona, New Mexico, Colorado, Nevada, and Utah. They are hot and dry, and the temperature ranges from 10 degrees Celsius to a whopping 52 degrees Celsius. They have low annual rainfall. They have a seasonal high temperature. They have a scarce water resource. Architecture on the climate. Houses and commercial buildings are typically constructed from adobe bricks, a commercial material made from mixing earth with other organic materials like straw or dung. The use of adobe bricks as a building material is critical in regulating the interior temperature of building during scorching days and freezing nights. Traditionally, houses featured windows to reduce sunlight exposure. Cooling systems such as air conditioner is vital in residential and commercial properties to provide conductive living and working environments. Okay, one sec. Now the Mediterranean climate. It's mostly in Northern California region. It's present for season while present for season while the southern part is only mildly affected by the phenomena. Generally, the state has a relatively narrow temperature range of between 10 degrees Celsius and 27 degrees Celsius throughout the year, depending on the season. However, the temperature of inland California can go up to a scorching 38 degrees Celsius during summer and the asphalt. A continental transform that covers a huge 1,200 square kilometer of the state of California. It is a plate boundary between between the Pacific plate and the Northern American plate. It's a region where the earthquakes are very common due to plate movements. And there's up to 1,400 earthquakes at varying magnitudes, hovering of around 5.1 megawatts, I guess, and sometimes up to over 7 are reported in California each year. Houses in California are built from bricks and timber. Brick houses often sustain less damage than timber houses, as brick houses are much sturdier and resistant to shock compared to timber. Building materials of high-rise and commercial buildings are often include steel, as it can withstand seismic waves caused by earthquake, equipped with adequate thermal regulation systems. And now the humid subtropical climate is located in the Gulf Coast, Lower Mississippi Valley, South Atlantic states. It's mostly warm throughout the year, with the exception of winter, where the temperature is usually cooler and mild. Temperature varies between 7 degrees Celsius and 22 degrees Celsius. There's high annual rainfall. Experience air mass clashes between cold, dry air from Canada and warm, moist air from the Gulf of Mexico. Vulnerable to hurricanes, floods, and even thunderstorms. There's the occasional tornadoes. The hurricane proofing. Timber is a common building material for those, as timber framing is stronger than most other framing materials. Houses are elevated with stilts to prevent food damage. Houses have optimal roof pitch for wind deflection. Some houses have circular structure to help transfer environmental loads like stronger winds. The use of reinforced walls and impact glass to prevent wind damage and inflow of water during floods. Enhanced insulation to maintain conductive internal temperature of houses. Okay.
Okay. Hi and good morning. We are Faris and my fellow classmates. I'm Tariq and I will be talking about the tropical climate of the United States. The tropical climate is located in southern Florida, the Pacific Territories, the Caribbean Territories, and the Hawaiian Islands. These include the states and territories of southern parts of Florida, Guam, Puerto Rico, northern parts of the Mariana Islands, the Virgin Islands, American Samoa, and Hawaii. There are two seasons in this region, which are summer and winter. This climate has a narrow temperature range between 10 degrees Celsius at the coldest and 32 degrees Celsius at the hottest.
Tariq, can you check? You are on mute, I think.
Oh, sorry. Okay. Is it on?
Yep.
Okay, sorry. In the tropical climate, an even spread of precipitation can be seen throughout the year. The most common natural disaster in this region is wildfires, which occur more than 1,000 times each year. Tropical storms and hurricanes are also common in this region, and other natural disasters include floods, tornadoes, and tsunamis. These are examples of the architecture that can be found in the tropical climate of the United States. Building materials for houses and commercial buildings are mainly comprised of blocks and bricks. Bricks are used to provide good thermal insulation, specifically to keep the interior of the buildings cool during hot tropical weather. Buildings are also water resistant to combat humidity and rainfalls. Most of the buildings are also made fire resistant to ensure less damage from wildfires. Buildings are also equipped with a good thermal cooling system like air conditioning to optimize the thermal environment. Now, let me explain to you the temperate climate of the United States. The temperate climate is located in the southern Great Plains, the lower Midwest, and the Middle East Coast. These include the states of Kentucky, Kansas, Ohio, Missouri, Illinois, Indiana, Pennsylvania, Virginia, New York, Connecticut, and New Jersey. There are 4 seasons in this region. They experience cold winters and hot summers. The temperature ranges from 2 degrees Celsius to a modest 32 degrees Celsius. In the temperate climate, strong winds occasionally occur. Hot and dry air from the southwest region travels to this region. On the other hand, warm and humid air comes from the Gulf Coast. Cool and dry air comes from Canada. This causes hailstorms, tornadoes, as well as forest fires. This region is said to have proximity to the Tornado Alley, which is a region in the United States where tornado outbreaks are frequent throughout the year, usually within the region of northern Texas, through Oklahoma, Kansas, Nebraska, Iowa, and South Dakota. These are examples of the architecture that can be found in the temperate climate of the United States. To accommodate the drastic changes in weather throughout the year, houses and commercial buildings are equipped with necessary features that aid the occupants in adapting to new weather during seasonal transitions. The buildings are often equipped with both heating and cooling systems to optimize thermal comfort during the winter and summer seasons, respectively. In the Tornado Alley, some houses are built with bricks, which provide a sturdier structure to minimize the damage caused by tornadoes. Now, let's move on to the humid continental climate of the United States. The humid continental climate is located in the northern Great Plains, the North Central Plains, the Great Lakes, and New England. These include the states of Minnesota, Nebraska, North Dakota, South Dakota, Illinois, Ohio, inland parts of New York, Massachusetts, New Hampshire, Maine, Connecticut, Rhode Island, and Vermont. There are 4 seasons in this region, which are spring, summer, fall, and winter. Temperature varies between negative 18 degrees Celsius and 27 degrees Celsius depending on the season. An even distribution of precipitation can be seen all year round. Certain states may experience rapid fall and rise in temperature as well as extremely strong winds due to thunderstorms and changes in air pressure caused by the temperature difference between one localized region and another. Air mass conflicts also occur between the Canadian and Gulf air, which often results in mid to severe thunderstorms and tornadoes. These are examples of the architecture that can be found in the temperate climate of the United States. Houses are typically built from timber and bricks for ideal thermal insulation during hot and cold weather. Most houses are equipped with heaters or thermostats to regulate the internal temperature during cold winters. I will now pass back the presentation to Ben for him to continue with the next part of the presentation.
Thank you, Tariq. Hi, everyone. So let us talk about the oceanic climate. So this climate is experienced in the Pacific Northwest as well as Alaska. The states involved are Washington, D.C., Oregon, Idaho, Montana, and Alaska. So the states in this region present 4 seasons throughout the year, including summer, spring, autumn, and winter. The temperatures of these states changes drastically throughout the year, ranging from a low of -1 degree Celsius during winter to a modest of around 26 degrees Celsius during summer days. Alaska, being located on the northwest extremity of the United States, has a much wider range of temperature from a bone-chilling -35 degrees Celsius to a high of 33 degrees Celsius, depending on the season. Humidity in this region varies according to the season, where it is usually cold and moist during winter, autumn, and spring, whereas during the summer, locals would normally expect hot and dry air. Precipitation, on the other hand, is usually constant throughout the year, and this region is occasionally struck by natural disasters like wildfire, floods, tsunamis, and earthquakes, to name a few. Now let us take a look at the architecture in these states. So houses are typically built from timber and bricks for better thermal insulation, and these houses are also equipped with temperature regulating systems like air conditioners and radiators to provide a comfortable thermal environment to the occupants throughout the year despite temperature changes. And these houses also often include large openings like floor-to-ceiling windows to let in more sunlight and heat during cold winters. Now, some notable architecture in this region include the US Capitol and White House, but both of these buildings are located in the state of Washington, D.C. Now, let us talk about the geographic features of the United States. Firstly, climate varies according to altitude and distance from the ocean. When it comes to altitude, temperature usually decreases as the altitude increases, specifically around 1 degree Celsius per 100 meters increase. That's why in mountainous regions, the temperatures are usually lower compared to other regions due to their altitude. Now, when it comes to distance from the sea, so water has a much higher heat capacity than solids, so it can hold more heat, right? So more time is required for the water to cool down or heat up. So land heats up at a much higher rate than the ocean. So hence, during the day, inland temperature is typically higher than that of coastal areas, whereas at night, the temperature of land drops much faster than the ocean. During that time, inland temperature will usually be cooler than the moderate temperature in the coastal areas. Here are some notable landforms in the United States. So these include the Appalachian Mountains, Rocky Mountains, Great Salt Lake, Grand Canyon, Great Plains, Mississippi River, Mojave Desert, and Death Valley. Now, all of these geographical features actually experience different climates from one another. Now, let us have a short comparison between the United States and Malaysia. So the United States is located in the North American continent, whereas Malaysia, on the other hand, is situated in Southeast Asia. In the United States, there are up to 10 different geographical climates, which include the 7 major ones we've mentioned before. And Malaysia, however, has only 1 climate and 2 monsoon seasons. Now, Malaysia's climate is categorized as equatorial climate or tropical climate, and this climate is actually similar to the one experienced in South Florida of the United States. The average temperature in the United States can range between negative 5.6 degrees Celsius and 30.6 degrees Celsius, depending on the region and the season. The temperature in Malaysia, on the other hand, ranges between 21 degrees Celsius and 32 degrees Celsius. Now, of course, in the US, they do experience much more extreme temperatures that could go far below or even above their average annual temperature range compared to Malaysia. Of course, much of the country experienced 4 seasons, whereas Malaysia only experienced 2 monsoon seasons, the southwest and the northeast. So that concludes the topic of climate. I will now pass the presentation back to Yusuf for the next part of our presentation. Thank you.
Yusuf, I think you are on mute.
Sorry, I thought I was not muted. Okay. Cultural diversity in the United States of America. First, let's have a brief history on the cultural diversity in the USA. Because of the country's horrible history of slavery, race is a continuous issue in the United States. African Americans have been subjugated throughout history, and Barack Obama's election as the first president was a watershed point in history of the United States. When you move to the United States, you may encounter people of many races. When people in the United States talk about diversity, they usually refer to the racial distinctions that they have in the country. The majority of the people in the United States are white and non-Hispanic. Other races are frequently referred to as minorities. The second largest group is has-beens and Latino Americans, followed by African Americans and Asians, Native Americans, Alaskan Natives, Native Hawaiians, and Pacific Islanders are some of the other racial groups in the United States. Many people in the United States are also are mixed races, or of mixed races. So that's basically a diagram about the numbers I just said. That picture displays the different races in the United States. You can get African Americans, whites, Asians, and so on.
Okay, but this is a quite long time ago. You mean the research is 2009? I believe that there should be more latest ones, right?
I mean, that's
this,
the
yeah.
one.
The,
Yeah, I
the
guess, yeah.
statistic you show here is 2009. I believe there is a more latest update because from what I heard, the number of white is decreasing.
Currently, yeah, like I also heard the same, like the number of mixed and the number of minorities are increasing.
Yep.
Yeah. Like I'll look it up and change it.
Okay. Yep.
Alright.
Move on.
Okay. Okay. Now let me tell you about the cultural diversity in Malaysia. Malaysia is a diverse country in Southeast, located in Southeast Asia, having people from many different ethnicities living there: Malays, Chinese, Indians, as well as other indigenous Papua communities are among them. Malaysia is an extremely diverse civilization with a wide range of regions, foods, cultures, and customs. The following is a breakdown of the country's demographics. Like 50% of the country is Malays, 22.6% Chinese, 11.8% is indigenous Putra tribes, 6.7% is Indian, 0.7% others, and 8.2% is made up of non-citizens. Okay, now guess I'm gonna pass over to Tariq again. Here.
Hello. Based on the earlier presentation, I would like to summarize the diversity between the United States of America and Malaysia in terms of climates and ethnicities. As you can see, both United States and Malaysia are extremely diverse in their own unique way. Generally, the climate in the United States varies according to the region, ranging from hot summers to cold winters. Malaysia only experiences the equatorial climate consisting of only heavy rains and high humidity climate. In terms of ethnicities, the US is made up of mostly white people, Hispanics, and African Americans, while Malaysia mainly consists of Malays, Indians, and Chinese. The similarity of both countries is that they consist of several other small minorities living together with the main ethnicities. It can be concluded that the climates and the different ethnicities living in the United States and Malaysia contribute to the different architectural landscapes of the two countries. We will now move on to the Q&A sessions of the presentation.
All right, so I'll be asking the first question. So in the United States of America, which state is located in the Mediterranean climate? Does anyone know this answer?
No, I don't know.
How about any of the student? Anyone? Does anyone want to give it a try? Or you could quickly Google it and answer it. So no one wants to give it a shot? All right, it's okay then.
Mediterranean. Is it the Ohio? Maybe I'm wrong. California.
Is it Ohio?
Okay. Really unfamiliar with USA, but maybe learning some. Putting maps when you are explaining would be easier to catch. You know, it's quite big country. We are learning. Okay.
We did include maps, but maybe we should have pointed it out earlier.
Yeah. Okay. Next one is 3 states.
Okay, second question. The 3 states in the oceanic climate region of the United States of America. Hello?
Oceanic climate. The one that facing the Pacific Ocean.
Yeah.
Yes.
Yeah.
So there will be New York area.
No,
right?
not New York. No, not
Sorry, New York is in the Atlantic Ocean.
I see. I can't remember the names of the states.
I'll give you a hint. Yeah. DC. What else? Well, Washington is one.
Washington,
Okay, bro.
Idaho, Montana, Alaska. I see. Wow. Mm-hmm. Okay, good.
Let's say, okay, so for the third question, in 2009, what was the percentage of African Americans living in the United States of America?
Is it 18%?
We shall see. It's 13%. So that is all from us. Thank you.
All right. Really good presentations to all of you. This group is quite lengthy. Hopefully, probably we can learn more with maps to help us, because not everyone can remember the name of the states or where is it located. For example, like me, I can't remember, but it's good to see that they are actually it's almost all kinds of climate is actually happening, and then when you are doing comparisons, you will learn a lot, right?
Yeah.
In this United States, they do not have a desert.
They do.
It's the Mojave Desert and Death Alley, sir.
I see. Mojave Desert to the Death Alley. That is actually central of the America.
It's in California, I think. Is it?
It's roughly like a couple of kilometers besides California.
Yeah.
It's on the west side.
Yeah. There are a few other deserts as well, though. They're like, yeah. I think deserts in Nevada, is it? Like, well, where Las Vegas is.
Mm-hmm.
Yeah.
Texas is also facing the desert climate. Is it?
Yeah.
Sorry, sir. Yeah. Yeah.
Mm-hmm. All right. I believe based on what we have meet today, the presentations by 3 groups, I believe some of you can see each other's weakness and strong points. Okay, so I hope you all can do better in the next presentation. Okay. Most importantly is always attach map so that we all can understand where you are pointing your information from, because it's quite hard for all of us to learn new stuff, especially like Australia or the USA and UK. They're all new things, so many things to know. So if you point out the locations, it will be quite easier for all of us to get what is happening. Okay. For the next presentation, that will be on the 5th of November. It is we are gonna talk about ecology, flora and fauna, and then the topic would be balancing nature. How human balancing the nature of ecology, flora and fauna. It is a very open topic. You can continue with your presentation just now. So, for example, format, style, and then because in the end you want to compile these all presentations for the final submission. Okay, so for the group Fabian just now, I believe you can upgrade your works so that it can be more flavorful. All right.
Okay.
Where those are?
Although you are only 2%, doesn't mean you can do less. But you know, you must produce good also. Okay. Just want to remind you, when you already done all 3 presentations, the compilation of presentation must be submitted individually. Okay. Then must follow the SEGI University assignment format in PDF mode. The submission will be emailed to me, and what you have to do is all the topics above, complete with date, snapshots, or any written explanations, question and answer. Okay, then what do you learn from each topic given? What do you learn is very important, because most of the time it's different from one person to another. Some people would learn more on the certain topic, or probably learn new terms, pronunciations, a country itself, and many things. Okay, and don't forget that communication, creativity is also given marks. Okay, so because we only 25%, doesn't mean you don't see it as an important mark. Okay, because another 25% would be the midterm test. It will be on the week 10, and then another 50% is the final. Just want to remind you all. Okay. All right, so we still have a long time to go. I shall continue with lecture today. Okay, so lecture today we shall continue regarding the principle of heat. Heat is a form of energy contained in substances as molecular motion or appearing as electromagnetic radiation in space. The temperature is the symptom of the presence of heat in a substance. Okay, means heat can be measured, but coldness you cannot measure. Why? Because coldness is only the absence of heat. So it cannot be measured. It's just an absence of heat. How to measure it? By using thermometer, of course, but thermometer can only measure the heat. So if there is an absence of heat, it will be the temperature will be dropped. Relationship of heat and temperature. The heat which is energy, is transferred from one object to another due to temperature difference. Heat is the energy and temperature is the measurement of the amount of energy. For example, A is the hot object and B is the cold object. If you put it closer together, it will the heat will be moved and transfer or convect towards the colder place. It is because of it's always move in that direction. Heat always move towards cooler or colder area. If it is touched, then convection will be happening. Okay, besides that, there are also units that you need to know. For example, velocity, which is the speed. The symbol is meter per second. Then acceleration, which is force, which is symbol would be the meter per second squared or kilometer and mass per second squared. So the unit velocity is increased in unit time, that which gives the unit acceleration in unit mass called Newton. So force is measured by Newton. And then energy, which is the work, is the work done when unit force is acting over unit length. In example, Newton times meter, then it will become joule. Joule is the energy for symbol in this case. Then power, energy flow rate will be under different term, which is energy flow in unit time or unit work done in unit time. In example, joule divided by the second per second, which is under watt symbol. So then pressure or stress is a unit force acting in a unit area. So it will be called Pascal. So all these are actually very different, but they are all related. Means that speed, and then you add force to it. When you add force, you can get the energy. When you have energy, you need to see the energy is moved. When the energy is moved, or you get this amount, and then the energy would have pressure. So the pressure would be called these different symbols. So that's how it is being measured. Okay. So the concept of specific heat, describe the connection between heat and temperature. The quantity of heat required to increase the temperature of unit mass of a substance by 1 degree. The unit of measurement is joule per kilo Kelvin, which is temperature. Latent heat. This is one of the nature of heat. Definition. The amount of heat absorbed or released by a substance during a change in its physical state or phase that occurs without changing its temperature. Two types of latent heat. Number one, heat of fusion, melting a solid or freezing a liquid. Then number two, heat of vaporization, vaporizing a liquid or a solid or condensing a vapor. Okay, means that vaporizing a liquid or a solid is you know how things happen. It's like from the sea and then you become cloud, and then condensing a vapor is like from the cloud becomes rain. So that is condensing. So that is the example of vaporization. Next would be the unit measurement, the amount of heat in terms of joule and calorie per mole or unit mass of substance undergoing a change of state, which is a joule per kilogram. Thermodynamics is the science of the flow of heat and its relationship to mechanical works. The first law is the principle of conservation of energy. Energy cannot be created or destroyed, but only converted from one form to another. Heat and work are interconvertible. The energy output is equals to energy input unless there is a plus and negative storage component. Second law of thermodynamics, heat transfer can take place spontaneously in one direction only. Heat is transferred from hotter to cooler body, or generally from a higher to lower grade state. Heat can only be transferred to the opposite direction only using a machine with an external energy input. Any machine to perform work must have an energy source and a sink. In example, energy must flow through the machine. Only part of this flow can be turned into work. So the heat energy is transferred from one object to another as a result of temperature difference. Heat flows from high to low temperature zone, so it can take in different forms: conduction, convection, or radiation. These three is how the heat is flowing, either absorbing into certain material or dissipate to the atmosphere. How is this going to happen? You start a fire using certain material, for example, coal. When you start a fire, the radiation of heat will heat the kettle, okay, pot, and then the pot is heated up, then it will heat the water inside that pot. So it is under from heating when the pot is become hot, and the water is I think it becomes convection. Okay, and then the pot that is very hot. Now it going to transfer the heat to the handle. When the transfer of heat using material to one and to another material, it is called conduction. That's why when you handle a pot, you will see the difference of material. For example, the pot, it must be in a steel metal material so that it can absorb radiation of heat faster, and then able to convect the convection of heat to the food that we are cooking. So it will be another transformation of heat. However, the flow to the handle, which is under conduction, it always being stopped by the usage of different material. Example, what is the example of material for the handle that you always see in the market?
Wood.
Yep, timber or wood. However, that would be one of the high-end expensive stuff. If you are looking for a cheaper handle material,
Plastic.
yes. But plastic also is very easy get melt by the heat. So it must be combined with other material, usually is silicon. However, you cannot use silicon alone because silicon is soft material. So they have to combine the two, plastic to silicon. So with that, they can create a stronger material, and then it becomes less heat transferred to the handle, right? Otherwise, how do you want to cook with the very hot handle? So that's how technology is been teaching us about how to use heat at the same time it is safe to handle. Otherwise, we always get burnt hand every day. Okay, so heat flow. Conduction within a body or bodies in contact by the spread of molecular movement. It must be in contact, then it becomes conduction. Convection, from a solid body to a fluid, vice versa. It is also mean to transport the heat from one surface to another by moving a liquid known as mass transfer. And radiation, from a body of a warmer surface to another which is cooler. So radiation that we can see here from the fire to the metal pot. Besides that, we also can directly feel the fire with our own skin, even though it is more distant, right? Because our skin has so many what's that called, cells to feel. So we can feel so many things, not only heat and cold, temperature, but also by touch. Touch also we can sense a lot of differences. If you touch liquid, it's different. You can feel the differences. You touch soft material like clothes or carpet, it will be different. Touching an ice, you can feel the ice is very cold, and then it starts to melt onto your hand, and it becomes wet. So all those things are actually happening with our own skin. Okay, so this is the definition, deeper than the definition of conduction. So when you heat, and then you want to transfer heat by different material, you can do quite fast. And then you want to, for example, you want to change the material shape. For example, steel, you want to do a sword or knife, for example. You must use very strong heat, and then you can actually change the molecule structure of metal by using heat. And then thermal conductive or K value. Definition is ability of a material to conduct heat. So when you are conducting the heat, it is under measurement of watt per meter, how to say this, area and Kelvin. I don't know how this, but don't worry, all these crazy mechanism, thermodynamics questions will not be in the exam, because we are architects, we don't do calculation like that. Those are for engineers. Engineers love to do calculation. If you like to do calculation, you can still be architect. Don't worry. All right, so conduction is like this. And this is a thermal transmittance or U value, the rate of transfer of heat through the structure divided by the difference in temperature across that structure. Example of wall section, there is a difference of conductance, U, transmittance, and then insulance. So with this, you can see that something is happening here. I don't know. However, if we talk about environment, then I know. The move caused within a fluid by the tendency of hotter and therefore less dense material to rise and colder, denser material to sink under the influence of gravity, which consequently results of in-transfer of heat. Example like when the hot water start to evaporate into the atmosphere, and then it's because of the transfer of heat is happening. The heat is moving towards the cooler place, and then it will be transferred. That the cooler air molecule is dropping to the ground, and then it will be heated up again by the hot water spring like this one. Radiation. Emission of energy as electromagnetic waves or as moving subatomic particles, especially high energy particles, which cause ionization. What you can see in the picture is that you are burning certain material to produce fire, and then this fire is controlled within a protective material, and then you have chimney to control the all the particles that is burned to one chimney or duct, so that the heat is actually controlled to a certain place only. So the radiation of heat is actually controlled through the opening that you can see in the picture. And then this radiation, you just put up your hand and you can feel the radiation of heat is transferring to your hand. Depends on properties of the surface. A decimal fraction indicating how much of the incident radiation is reflected by a surface. The symbol is mu. Sorry, this is not mu. This is different symbol. Radiation also depends on properties of the surface. Sorry. Absorber and then emittance. The decimal fraction, a measure of the ability to emit radiation relative to the black body, the perfect emitter. For an ordinary surface, the same wavelength or temperature of radiation, but many surfaces have selective properties. High absorptance for solar radiation, but low emittance of ordinary temperature. This is one example. The surface is useful for absorber panels of solar collectors. For example, like this one, for example, the glass. This is a glass, the blue color. And then solar radiation heat the glass, and then certain of it will be directly transmitted radiation into the atmosphere of the inside. And then this angle is actually showing that how it is reflected back. If it is this angle and the reflection would be also same angle, and then the radiation is absorbed into the material and become warmer, eventually become hot also. And with this absorption, there will also happening a second transmission of radiation. So this can be transferred either back to the atmosphere or into the other place, or for example house. So thermal behavior of a building, it will be internal heat gain, conductive heat gain and loss, solar heat gain, ventilation heat gain or loss, evaporative heat loss. So evaporative heat loss is very important that we want, because if you have a hot roof, then you want it to be evaporate fast before it can enter into building, become a internal heat gain. Yep. So the thermal behavior of a building, we already know this 5 methods of way to heat gain and loss. A building gains heat from exposure to solar radiation, exterior temperature, humidity level, building occupants, electrical lighting, and also electrical appliances. So all these are sources of heat gain. And then how will be this happening? How to calculate it is all of the accumulated heat gain. Building losses heat from uninsulated building components, for example, wall, ceiling, roof. If you don't have insulation in these three material, then it will be lost quite fast. Then next is the exposed wall and ceiling. And then next, through window, door, and floor also can happen heat loss. And then infiltration of air leakage. Air leakage was something that you very seldom happening. Malaysia, it don't really matter air leakage, because in general outside and inside of a building is almost same temperature, unless you are turn on the aircon and then make the temperature drop less than 20. Then you can feel the air leakage. Air leakage means again you must see the situation where the hot air is moving towards the cold. So if you are in Malaysia, for example, you are having a very cold aircon room. So if the window is not solid proof, then there will be happening air leakage, where the atmosphere, the outside, the environment has warmer air. It will be penetrate the warmer air through the air leakage. Means that there is a tiny, super tiny hole inside the window that you don't see, you can't see with your own eye. So what you can feel that suddenly there is a warm air coming in through the window, although it is not open. That is also called air leakage. On the other hand, if it is in the cold climate country, for example, if it is in the winter in the UK, all right. So winter like that, there will be happening like you know, the building is warmer and then the atmosphere is colder. So the air, the heat movement is from the warm to the cooler area. So what happens is air leakage will go the different direction, which is warmer air inside the building is going out through the tiny hole in the window, and then goes out to the atmosphere because it is cooler out there. And then air temperature, air pressure has already changed. When that happening, when the air pressure is already happening, then cooler air will come in through different direction or different location. For example, it is coming from the underneath of the door, because most of the time underneath the door is having quite big gap for air to come in or out. So because of hot, cold air is heavier and it will stay low. So what they do is they come in through the door, and then you can feel suddenly it's like a ghost. You know, when you are sitting in a room where the room is actually warm, and suddenly there is a cold air coming underneath the door. You already closed the door, but the cold air is coming underneath the door, and it comes like you know, it feels like something greeting you in the face. You thought it's a ghost, but it's just a cold air because of air leakage. Okay, so that's what happening in the air leakage. And then brick hailstone. What's happening here is because heat is stored when you are in a building where there is material can absorb the heat and then release the heat during the night. It's what happened when you are far from the sea. If you're nearer the sea, then the it's different in terms of changes. And then water. Water, it can happen like this. For example, during the day, the sun is the sun is actually directly towards the glass of water wall. So this will create a what's that called cooling process. So it will allow the cooling material, cooler air come in, and then the warm air is actually becomes changed because of the water is actually reduce the heat. And then because of that, during the night, it also adjusts itself because since the day, this water wall absorbing all the heat, absorb all the heat and then release cool air inside the room, the house. And then when it is night, this, you know, the water is already absorbing a lot of heat, energy. So what it do, it release all this energy during the night. So the air which is already cool, it becomes warmer again. Thermal mass is where material of high thermal storage. High thermal mass material can act as a storage for both heat and cold as they heat up and cool down relatively slow. The amount of thermal mass in a building had an influence on the effectiveness of the heating and rolling discharge operation. The amount of the stored thermal energy. Time lag. Decrement factor. Insulation. Also very important to know. The use of material in low overall conductance to reduce energy flow across another material. This is the important thing. Insulation function is to retard or to reduce the flow of heat. High resistance being the inverse of the conductive. Conductance, worst conductor of heat are grass apart from vacuum. I'm sorry, gases, not grass, sorry. This allows them to be the best insulator because convection within the gas can be suppressed. Thermal insulation like this, you can see what's happening here. So the outside of the building is brick wall. Okay, inside there will be a very thick insulation. Usually it's called rock wool or glass wool. And then, you know, it is a wool, but it's not made of sheep wool. It is actually wool material from construction material also. If it is called rock wool, it is actually from sand or something like that that is compressed into wool, so become soft. It's not compressed, become hard. Compressed becomes soft like that. And then on the right, which is a slightly grey bluish color, this is actually the example of drywall inside the building, where you need to first is to control the insulation not to move around, and then there is also like a lock. You can lock the position so that it cannot move with the brick. So this, you can see there is a tiny steel here. It's actually to tie together with the brick. So thermal insulation, you can see here, this is the brick, and then this is the insulation material, and behind it is just the drywall, and behind of this drywall you can have your own house or room or office or whatever. So there are three types of thermal insulation: resistive, reflective, capacitative. Resistive, able to insulate through its resistance to conduction characteristic. Reflective, is able to absorb or omit infrared radiation, depends on both of the nature and color of each surface to reduce radiative heat transfer. Capacitative insulation, it is able to absorb a certain amount of heat and provides a delaying effect for heat flow. Calculating building material, what is the surface, external surface, clay brick, glass mineral, wool, concrete blocks, cluster, internal surface resistance. So the R value would be like this. The thermal transmittance for the overall wall element is 0.24 watt meter square Kelvin. Heat absorption and heat transmission. Heat energy is exposed to an object, then we move to the heat energy that is actually cooler, and then they transfer from warmer to cooler. Okay. Heat absorption and heat transfer. Transmission, we already learned about this just now. Convection, conduction, radiation, only three. Absorption and heat transfer. Okay, so start with solar radiation, and then the heat gain into the building. After it hits the roof, it will radiate inside the house, and then heat gain happening. However, when it is rain, when it is rain, then the roof of this side become condensed. So when it is condensed, it will clash with the heating material. So this energy will absorb into the water, and then that energy will remain the rest. Heat absorption and heat transmission. Insulation system. Sky shows high level of heat insulation without any mark of thermal failure. Okay, so that's all for the lecture today. I don't know if you understand or not, but yeah, this is quite this is quite advanced in terms of teaching, especially you guys. What you need to understand is heat, there is a way to control with our the studies. Not only me, I mean many people, thousands of people studies about how to control weather. I mean control the temperature of the surrounding. You can do that by so many things, activities, and this is how you want to insulate the heat. But the above is how you to understand heat movement. Okay. So if do you have questions regarding regarding heat? Principle of heat. Do you have questions? You mean need more explanation or something?
No, sir. Shortly.
All right. You already complete the principle of heat. Next class will be teaching different one, different topic. All right. So if there's nothing else to discuss, I just hope that all three of the group continue with the next topic, which is ecology. Still same, using the same country, okay? And then you can what's that called? Improve the next presentation so that it can be more factual, more facts to present. If you have questions regarding the presentation assignments, you can ask in the group, okay? Don't be shy.
Will do, sir.
Okay, so far that's all for the class today. We shall meet again next week. Thank
Sir,
you so much.
excuse me.
Do you have questions?
Yes, I'm sorry. It's about this module. Do we have when is our test for this subject?
Hold on. Actually, already I give already the lesson plan previously. Okay, so we are already here. This is the week 9, 3rd of December 2021 is your midterm test.
So our topics will be covered until lecture 7.
Yes.
Okay.
And then submission of the assignment will be on this 10th of December, and then exam week. After that, we are finished. All right, so it's already, I believe I already gave this lesson plan also, right?
I wasn't here in the first 2 weeks, so sorry.
But I think I passed to you to your own individually.
Oh, I see. Sorry about that, sir.
Never mind. Yeah, only this way. So you are still here. I purposely made the lecture slightly advanced because if we can clear this week, these 2 weeks, lecture 9 and 10, means that you have more time for the studio projects. You understand, right? Studio projects needs a lot of focus to do a lot of work, right? So if I can clear this lecture 9 and 10 earlier, it would be better lah for you. Okay, so that's all for the today. More questions?
Sir, is the test MCQ?
No,
No. Oh,
no MCQ test.
okay.
Other questions? MCQ is for schools, but we are not school, we are university.
Yeah, true.
All right, so if you don't have questions, we shall meet again next week. Thank you so much. Have a good weekend.
Thank you, sir.
Thank you, sir.
Welcome.
Thank you, sir.
Welcome. Goodbye.
Bye, sir.
Sir.